Assalamualaikum warahmatullahi wabarakatuh. Okay, I will explain about the hypergeometric distribution. Okay, hypergeometric distribution is just like Bernoulli distribution, which is considered n number of samples and I numbers for success and number for failures. Okay, but another thing that should be considered in hypergeometric distribution is n numbers for good selection and n numbers for bad selection. Okay, this is the PDF for hypergeometric distribution, and this is the mean and also the variance for hypergeometric distribution. Okay, the first scenario, the selection of 5 cards represent the number of n samples taken, and the probability of getting 2 red cards is represent the number of success. Okay, while in a deck there is 26 red card, which is represent the n number of good selection, while the balance is the number for bad selection, and there is 52 cards in a deck. Okay, the next scenario is a wallet contains 3 $100 bills and 5 $1 bills. You randomly choose 4 bills. What is the probability that you will choose exactly 2 $100 bills? And the third scenario, you suppose you first randomly sample 1 card from a deck of 52. Then, without putting the card back in the deck, you sample second, and then again without replacing cards a third. Given this sampling procedure, what is the probability that exactly 2 of the sample cards will be S's, which is 4 of the 52 cards in the deck are S's. Okay, that's all. Thank you.
The gamma distribution. The gamma distribution is a general type of statistical distribution that is related to the beta distribution and arises naturally in processes for which the waiting times between Poisson distribute events are relevant. Gamma distribution have 2 free parameters labeled alpha and beta. The probability density function. The cumulative distribution function. The moment generating function. And the mean and variance for gamma distribution. Scenarios. Suppose you are fishing and you expect to get a fish on every 1.5 hours. Compute the probability that you will have to wait between 2 to 4 hours before you catch 4 fish. Second, engineers designing the next generation of space shuttles plan to include 2 fuel pumps, 1 active and the other in reserve. If the primary pump malfunctions, the second is automatically brought online. Suppose a typical mission is expected to require that fuel be pumped for at most 50 hours. According to the manufacturer's specifications, pumps are expected to fail once every 100 hours. What are the chances that such a fuel pump system would not remain functioning for the full 50 hours? Third scenarios, defect in a type of wire follow the Poisson model with rate 1 per 100 meter. Find the probability that the fifth defect is located between 450 and 550 meters. Thank you.
The double exponential distribution, also called the Laplace distribution, is the distribution of difference between 2 independent variables with identical exponential distributions. Consists of mu as a location parameter and b more than or equals to 0, which is sometimes referred to as the diversity, is a scale parameter. If mu equals to 0, b equals to 1, the positive half line is exactly an exponential distribution scaled by half and called standard double exponential distribution. Probability distribution for double exponential is expressed as 1 over 2b exponential negative x minus mu absolute value over b. The CDF, the moment generating function is expressed as mt equals to E mu t over 1 minus beta squared t squared, where t absolute value is less than 1 over b. Expected value is given by mu, and variance is given by 2b squared. Scenarios using double exponential distribution. First, this distribution can be used to model the errors, provides a motivation for the use of LAD or L1 regression, in which parameter estimates are based on minimizing the sum of absolute values of the residual rather than one least squares. The distribution can also be applied for atom decay with probability theta dx in the time interval x to x plus dx exclusive if it still exists. The third scenario is the distribution is also used in speech recognition to model priors on DFT coefficients. The addition of noise drawn from a double exponential distribution with scaling parameter appropriate to a function's sensitivity to the output of a statistical database query is the most common means to provide differential privacy in statistical databases. Thank you.